Welcome to a lesson with Dr. Powell. Let's look at an integral of a function where we can't take the antiderivative very easily. So instead, we use a Taylor series to help. Okay, let's start with 1 plus x to the 1/2. This has a Taylor series expansion. And we're going to give the name to the coefficients as this. 1/2, choose n, whatever it means. It's not quite important, at least at the moment. If we just think of whatever this is as being named this, the coefficient of x to the n just has that name. We'll go into detail on what this is, or remember what it is via the binomial Taylor series formula. But we'll get to that and remind ourselves of what that is in just a minute. But first, let's see what's happening. This is not the same as this, but it's almost. Now it is. All we did was just stick x cubed in into here. And so x cubed is raised to the nth power. So it looks like x to the 3n. Then we integrate. Oops, 0 to 1. We integrate. And this can be done term by term. So let me get this, and integral 0, 1, 1/2 n, x to the 3n dx. All right. Now, this is a constant at index n here. And so in taking this, we take the antiderivative. And we evaluate that from 0 to 1. And we end up getting just 1/2 n 1 over 3n plus 1. Okay, so this series right here has no x's in it, just n's, is equal to that integral, exactly. So we're going to approximate this integral by just adding up some of these terms. How many terms do we need to add to get within, let's say, 0.1 of the actual? Well, let's look at what this is now, this coefficient. We can think of it as a fraction with n factors on the bottom and n factors on the top. On the top, start with 1/2 and just go down by 1 repeatedly until you have n factors on the top. So that would be 1/2 minus n minus 1. Since this is like -0, -1, -2, -3, all the way to n minus 1 would give you n things on the top. On the bottom, you have n things starting at 1 and just going up by 1 until you get to n. Now keep in mind, so this is just 1/2 n, but we're also multiplying it by 1 over 3 n plus 1. Also notice that these terms now in this view are alternating in sign. So we can use the alternating series test in order to bound the remainder, which is we add so much and then the remaining bit is past a point. The first term in that remainder in absolute value bounds above the whole sum of the remainder. So the remainder is bounded by the absolute value of the first term in the remainder. So we just need to see when we get a term in here, which is less than 0.1 in absolute value, so that, and then that tells us what the first term of the remainder should be. Let's just try some things out. At n is equal to 1, the absolute value of our term is a half over 1, but then also in the denominator is 3n plus 1, so it'd be 3 plus 1, so 4. So it looks like you have 1/8. We're already extremely close. We're only 1/8 away if the first term is n is equal to 1 in our remainder, and there's only one term before it, n is equal to 0. So using one term is even 1/8 away. Perhaps using two terms is enough then. Let's see. And n equals 2. Let's see, we have a 1 times 2 and a 1/2 times 1/2. So that's 1/4. And here we have 1/8. 1/8. And then here we have 1 over 6 plus 1. So 7. So yeah, so we got 7 times 8. Yeah, that's 1 over 56. 1 over 56 is enough for it to be less than 0.1. So we end up seeing that that should work just fine right here, 1 over 56 at this. Now, of course, we have to remember the alternating series test also requires that the terms be decreasing. And are these decreasing? Well, you can plot a few just to see if you like, or kind of go through this a little bit. Maybe think about cancellation slightly. I mean, anytime you get these numbers appearing up here, this 3 and 5, at first, those are going to be canceling out with numbers you see down here a little bit, at least eventually to some point. But it's also not growing fast enough on the top as it is on the bottom with this factorial. This factorial down here is growing a lot faster than that one. So it actually is decreasing. Now that's just not a rigorous argument. Nonetheless, let's take it for granted for now. And we have that the alternating series test allows us to only take the first two terms of the sum, 0 and 1. And then the first term of the remainder happens when n is equal to 2. Thanks for watching.